Folks, hello and welcome to your Week 3 discussion post. We're officially a third of the way through the course at the conclusion of the week, so I hope everybody's enjoying the course and having fun as we've gone along through the material to this point. To get started this week, as a reminder, make sure you have your calculus identification number handy. It looks like you're only going to be using one of those digits this week, but obviously make sure that's handy, so you can make the correct substitution here. I actually took a cut and paste off the discussion board so that I didn't lose any of the detail here as I walk you through this. So the scenario here, it looks like, and I'm not a coffee drinker, so I guess this could probably apply to any liquid, but if you're driving in your car and you got a beverage, we obviously don't want the thing to spill and make a mess. So let's be cognizant of where the centroid or the geometric center of your beverage happens to be. But it says, let's see, your car has no cup holder, so you must place your filled coffee cup on the passenger seat beside you when you start out in the morning. Bitter experience has taught you that the cup is least stable and most prone to spill when it is completely full, but becomes more stable as you drink the coffee and thereby lower its level in the cup. The picture on the left, here's your picture that we're referring to, shows a coffee cup partially filled with coffee. We will assume that it is the most stable when the centroid, or again, the geometric center of the cup plus coffee is lowest. Assume that the centroid of the cup plus coffee is represented by the function of the depth y. So the centroid is a function of the depth of the cup of the coffee in the cup in centimeters, and it's given by this really crazy looking rational function here, where again y is the depth of the coffee in the cup, and obviously y can range here from being empty to being full, or from 0 to h. Then it says calculate the optimal depth y of the coffee in your cup, and here's a very, very helpful hint. It says the centroid function is lowest when its derivative is equal to 0. Round your answer to the nearest whole number, include the sketch of the centroid function f of y, and verify your solution graphically. So a lot going on here, a little calculus work for you, and also some graphical work, and we'll see the value of the graph as compared to your computational work here once we get through all the pieces here. So the first thing, let's, a little bit different than the discussion from last week, the centrifugal force function, that was defined as simply as f of c, or I'm sorry, not f of c, but f sub c, just to say the centrifugal force. It actually did not show you the variable. Remember that that centrifugal force was defined as a function of velocity, but here we're just saying, we're just giving you, strict function notation here, f of y, and again, that's the centroid as a function of the depth of the coffee y in your coffee cup. So here we're going to work with just f of y, and so what I want you to do first is I want you to take this function, go find your value of c in your calculus identification number. There's two spots where you're going to sub it, one here in the numerator, one here in the denominator. Once you do that, you're going to have some work to simplify, and then you'll simplify f of y as best you can. The next step here, because again, in the hint, a very generous hint here says that the centroid function is lowest when its first derivative is equal to 0. So from a notation standpoint, again, what you saw in the textbook, this f apostrophe of y does designate denote the first derivative of this function. So let's write f prime is how we would speak this, f prime of y, and then you will find the first derivative of this function. Since this is a rational function, you will be using the quotient rule, and that is explained in your textbook. So two steps here, define your function f of y with your given value of c from your calculus identification number, and then take the first derivative using the quotient rule. The next thing you're going to need to do here is you're going to have to set whatever function you come up with here. You're going to have to set that function equal to 0, and you're going to have to solve for y. And my guess is that when you take that first derivative and you simplify the function, and once you set that equal to 0 and you want to solve for y, I think you're going to find that you're going to probably need the quadratic formula to solve that. And my note here to you says here you find a great application of the first derivative to see where a function is optimized. And remember, we said that the centroid is or the cup is most stable when the centroid is at its lowest. So when you start talking about that in the context of a derivative, that lowest point will be you'll be able to see that very nicely when we go to the graph. But this is really kind of an optimization step here that we're going to execute using the first derivative of the function. So before we talk about the graph, let me just very quickly one more time take the given function of y, substitute your value of c from your calculus identification number, simplify the function. That's the first step. Step 2, and again, I want this step to start with f prime of y, and again, that indicates the first derivative of the function of y. So you're going to find the first derivative of f of y, and again, since that's a rational function, you're going to be using the quotient rule. Third step, once you have found that first derivative, you take the first derivative, that function, you set it equal to 0, and you're going to solve for y. And these are the values, or essentially going back to how y is defined, that will be the height of the coffee in the coffee cup, and that's the point at which the cup is going to be most stable. And again, that may require you to use the quadratic formula. So after you've done that, what we want you to do next is go back to your original function after you have substituted your value for c, and we want you to graph that function. I left you a note here. If you go into the course and you click on modules, before you get to any of the weekly modules, there is a subsection called course-specific resources, and in there you'll find some graphing tools. So let me just point out something to you here very quickly. This function, because of the second degree term here in the numerator, you're going to find something, it's not going to look in whole like a parabola, but what you're going to notice is you're going to notice a very, very clear and distinct minimum value in the function when you graph it. And when you combine that with the idea that you have that you're looking for the derivative of that function and where it's equal to 0, what that means visually to you is that as you start taking tangent lines anywhere on this graph that you're going to find here of f of y, the point at which your tangent line is horizontal, you know that the slope of that line is 0, and that tells you that's where the derivative is in fact 0. So what you should, or what you're going to validate here is the fact that where that derivative is equal to 0, or where your tangent line would be parallel, you can say parallel to the x-axis, or it's flat, is where the derivative is equal to 0. And that point on the graph, that value of y, should be the value of y that you find here when you set the first derivative equal to 0. So it's a good way to corroborate the computational with the visual and the visual with the computational. And so it should all come together very nicely, and it's a very nice problem to see the relationship between the computational and the graphical. So again, a couple, 3 very clear steps here, and then a graphing tool to graph the original f of y function. And again, where your tangent line is has a slope of 0, or it's parallel to the x-axis, you'll know that's the point at which on the graph that should coincide with what you found numerically for the value of y. And again, good example to see that. Finally, as we always do, let's talk about the rubric. 3 criteria. 1 very solid post right up front. If there's any work that needs to be cleaned up, I will let you know within a day. Please make sure that you take a look at my feedback and you repost your discussion as necessary. Excuse me. And then finally, make sure you're using an equation editor to submit your work. Have a great week, and I look forward to seeing both the computational and the graphical work here.